a Carberry basket type reactor. It's a mixed flow reactor. So a mixed flow reactor. So I said this data was gotten from the lab. So they said we should design an actual, no more lab work now, an actual plug flow reactor. So the way you can link your lab work with your field work is by finding the rate of the reaction, because the rate doesn't change. So to find the rate, since this is a mixed flow reactor, this is the common situation of a mixed flow reactor.
I've never heard of that Carberry type before.
So if you reach graph, don't use this graph.
Okay.
Just
So this is the performance equation for a mixed flow reactor. Here your rate is giving us
Wait, you said this formula is the formula for what? Okay, for mixed flow.
If you let me, I'll tell you whatever.
So from the question, we were given FA naught, we were given W, they were not given XA, they were given CA. So we have to convert CA to XA. So how do you convert CA to XA?
CA is equal to 1 minus
CA is giving us,
CA.
no, we're looking for XA. So XA is giving us what? 1 minus CA over CA naught over 1 plus EA CA over CA naught. Where EA is giving us number of moles of reactants, 1 minus number of moles of reactants of the product minus number of moles of reactants over the mole of
That's one reactant minus product.
yes. Let me just write it. Sorry, product minus reactants.
Okay, product minus reactant actually. Okay. Over
reactants.
reactant, okay.
So XA becomes, if we put 0 here,
1 minus CA over CA naught.
so going back to the table, XA will now be 1 minus CA over CA naught.
Okay, so sorry. Where is the CA naught? Yeah.
Yeah?
In the question, was it given the
See,
question?
they're giving the equation as 10.
Okay, CA naught is done.
Yes.
Okay.
So where's the calculator?
See calculator now.
Why they ask questions with the cow go front to
So 1 minus CA over CA naught is 10. So we have 0.2, 0.4, 0.6, 0.8, 0.9. That's what we have.
use that formula.
Yes. So now our rate is giving us FA naught over XAW. So rate minus RA. Let me say this is equation 1. This is equation 2. So you get this XA using equation what? 2. You get this one using equation 1. So this rate is now FA naught XA over W. That's F X W is 0.1. Remember that it was given as 100 gram, like 20 kilogram. 0.14, 0.2. We have 0.28, 0.42, 0.4. We have 1.68, 1.67, 0.6. 2.5, 0.8. 2.5, 0.8.
See, you still change the W to 0.1. Okay, yeah.
Yes.
1.25, 0.9. So this is our rates. Now, so that once you find your rates, you can now go to the field. Should So we have our rates now. So we can now proceed to the field. So from the question, they said we should design a plug flow reactor. they gave us some details. So designing a plug flow reactor. I would advise in the exam you can solve this one first. Then this table should now come under.
Okay.
Remember, because so this formula we used to get the table. So it doesn't make sense that you have your table in formula exam.
Okay.
So solve first, then the table will now come under. So designing a plug flow reactor. So the details that they gave us. They said, yeah, they said X is 0.8. They said FA naught is 1/200. They said CA naught is 8. So we should find W. So what you do is very easy. For mixed flow reactor, for plug flow reactor, you have that W over FA naught is equal to integral of the XA over minus RA. While looking for W, we know FA naught. We know this XA is not, this is an integral, so it means that there are different values of XA, it's not just one value.
Okay.
So we have to find that XA. We're not, okay, now you have XA here, but you cannot use this XA because this XA is a function of this CA naught that we got before, which is 10. But we are no more working with this CA naught, we are working with a new CA naught of 8. So you have to use the undiluted results, which is this CA that was given in the question, the original question. So let us convert this XA to CA so I can work with this original CA that was given. So you know that from this equation 2, XA is equal to CA naught minus CA over CA naught. You agree with me? If you multiply this. So, and this simply means what? Okay, this is a change. So if I were to put it inside here, so this will become D. This is XA. This is a change. This will become D. We are putting this XA inside this become CA.
Over CA naught.
Over CA over minus RA. It's equal to what?
Okay.
So this becomes the CA over CA naught minus RA W over FA naught. You can take CA naught.
Outside WCA naught.
CA naught.
Over FA naught. Equal to CA. Okay. Yeah.
Now we want to find the area under this curve.
Okay.
Then they told us that at X is equal to 0.8. So we have to put in our limits.
Yeah.
We have to put in the limits. So they said at X is equal to 0.8. So which limit do we use now? CA naught. So to find okay, CA naught is 8 now. CA naught is 8 now. To find CA using this formula, CA is equal to CA naught into 1 minus XA.
Okay.
So that CA becomes 8 into 1 minus 0.8, which is equal to what? 1.6. So we are going to find WCA naught over FA is equal to integral of 1.6 or 8 to 1.6 actually.
Why do you have to do this?
Which one?
Why? Okay.
We want to find the limits, yes.
Okay.
We want to find the limits.
Yeah.
So we now plot our graph. So where's that graph plot?
Okay.
For us to.
What's the graph for
Are you sure? He brought out the graph now.
He brought it.
minus 1 over RA. So what is minus? So 1 over minus RA. That's what we're plotting. We put the phones when you want to start. If someone wants to steal it, and see how you just move this file.
I swear, they don't move on like this, so.
Level this for the rest of the trouble all your fault.
How? So we have 3.57.
Professor PP crashing in the UK.
That is it. Cloud 9.
Yes.
Investment don't crash. Don't crash for years.
Alpha.
3.1.
Silver,
One-
which
now
drink
one
you
minute.
Which RA are you using?
Anyone.
Anyone, okay.
Okay, go get me this drink. Nutri-You.
Okay.
Nutri-You.
Nutri-You, okay.
Which of the RA
This
is?
one, see now, 1 over R. It's only 1 R.
Okay.
1 over all of them.
For lab now. Okay, the rates are the
I
same.
say that rate is constant. The rate
Okay.
does not change.
Okay.
Okay, the rate does not change. The rate doesn't change.
Alpha.
So let's
Wait, that 1 over RA is basically 1 over RA.
1 over R, yes.
Like
1 over this one.
1 over that.
Yes.
Okay.
So let's plot this graph. Plot this graph. Cool. I have one app that can help you reduce equality, but you could just send it to the YouTube channel.
Is it possible?
Yes, I can give you the login.
Okay, better.
Okay, I'm going to try the rain now. So this is 1 over minus RP, and this is CE. So we have 0 against CE, yes. 0.51, 1.52, 2.53, 3.54.
So if you are to get this in your hand, this is 0.0.
Yes, someone will get it. Against CA, this is 1, 2, 3, 4, 5, 6, 7, 8. So at 3.57 we have 8. So this is 3.5. This is 3.5. This is 3.6. This is 3.7. The 3.57, yes, this is 3.5. 3.57, sorry, around here. And this is 3.6. Then 0.6 to 6. This is 0.5. The next one is 0.6. Then 0.1 to 4. This is 0.5. This is 0.1. 1, 2, 3. Yeah, this is 0.1. To 4.
Is it 4 or 6?
4.
Okay, okay.
Then 0.05 to 2. 0.05 to 2. And 0.09 to 1.
You manage this one.
Sounds well. So let's now plot our graph.
Well, the first value was
Okay, doctor. All right.
3.57 to 8.
why is your graph starting from there?
Yeah?
Why did you start drawing from here?
Oh, it's 0.05.
Okay, I just joined it to the origin.
That's not original.
Okay, I should have joined it.
Yes.
I just followed the
Straight line.
Wait, no, but you get my point now. I think it's supposed to start from 0, like the origin up.
No, it's not a straight line.
Is it if that's a
Like, there is no value here now.
I understand. Even though you took from
And
here,
if you trace
you
this
see
one,
trace and go straight
so
now.
that
We don't know
we
the
are
point.
tracing it back.
You get the point.
I don't get to.
Even though you draw from the origin like this,
Yeah,
you
you still get the same
straight
value.
line.
Okay, Trisha, that. What's the.
I don't want to do like to do something like this. And
Is it wrong?
No, it
It's
does
not
not
wrong,
really
but
matter. But it does not really matter.
Yeah.
So this is what we have. So we want to find the area under this curve. But they told us something, and I'm thankful that someone raised the question. So you're the one that raised the question. Because the question said we're integrating 1.6 to 8. So from 1 point, this is 1.5 to 1.6. So I'm getting from this one.
That's the 80%.
Yes.
Well, this is for Admira yesterday. oh.
So finding this area 1.6 to 8.
But Sha, we don't need to do the shade in the exam now.
You can do it. oh.
You should do it now so that they'll know that what you're finding.
Yes, that's how. Now, now you all get so. Now, this is for the party here. Me and the two for it.
As a matter of fact, you could
Yeah,
even,
so
I don't want to take any chances.
before you even start solving it, you could even draw that Carberry basket router.
Okay, yes, it was giving the question.
Yes, or if you don't want to draw, you can just draw and just do something of this nature.
Was he?
You can just do something of this nature.
You draw something like this. Person.
Okay.
Okay. So that's the same
Okay,
question, so-
because this is the
Yes, mixed flow
lab,
reactor.
the one you
Mixed
and it's
exactly.
a mixed flow.
Yeah.
So you have a mixer.
Then this one I say designing a plug flow reactor. You can now draw something like this. Plug flow reactor.
So when you are now mark, oh,
Yes,
okay.
now. Just something like this. Going in, going out. Then when you are done, you don't put in the values. So you can put FA naught is equal to blah blah blah. But when you do these things, you would earn more marks than someone who just
Who did it so plain and stuff?
Correct. Ah, you know, I
So
Yeah, the answer
we have to divide this thing into an even number of strips. So like some scholars have said, you just you want to divide it into 4 strips. So you say, let's say 8 minus this one is 1.6. 1.6 divided by 4. So we have 1.6. So it means that the distance between every strip should be 1.6. So this one is 1.6, right?
Yeah.
This is where we're starting from. So you just say plus 1.6. So meaning that you count 1.6 after it.
Yeah, okay.
So you're going to get 3.2. So when you count 1.6, you get 3.2. So the next point is here.
Okay.
This is my first strip.
This is our first
This
step,
is our-
okay.
So plus 1.6. The next one is what? 4.8.
1.8.
4.8 is here.
Second
So the
one.
next one is what? 6.4. 6.4, so 6.5. 6.4 is here. While the next one automatically gives us 8.
Ah, correct.
So these are the number of strips that we are working with. This. Hello? This. And
Hello?
so from Simpsons rule.
Okay, so I'm going to back from close from outside.
From Simpsons rule.
Yeah.
The one that has to do with
Then class.
y naught plus 4y1 plus 2y2 plus 4y3 plus 2 blah blah. Okay, I think
Right?
I've gotten it.
Where delta x is equal to b minus a over n.
Okay.
So what is our delta x? 8 minus 1.6 over 4. Yes. That's n is the number of strips, which is no n is 1, yes, which is 4. Then b is the
Correct.
here. Then a is
The starting
start point. So you know that they can change the I don't think we will change the x. If it's saying find at 75 this thing percent, so it means that this one will be 0.75.
Okay.
So whatever you get as that answer,
Yeah. You
that's
start
the
from
way you are going to
starting point.
So you get 2.
So from start from okay.
You have one from 2. That one is even easier. You say 2
Then 4,
4, 8,
is
6. Check it.
Yeah. 2 to 4.
Okay,
yeah.
that's 3 strips. Okay, that's only 3 strips. You can see.
Why if you use 2.5, 2.5? Sorry, like 1.5.
8 minus 2 is 1. Yes, you can use 1.5. So this is 1.6, right? So putting it here, A now becomes 1.6 over 3 into y naught.
Yeah.
You come to this first one, where you are starting from,
Yeah.
you trace it here. That's 0.5. 0.05 here. Plus, you come here, you see 0.05.
Yeah.
This one. Plus, then we're using something else. That one guys. Plus, this is 0.1. This one plus 4 into is 1.05.
Sorry, boss. That means each line like this line is what? 0.05.
Yeah, 0.05. Yes. So the last one is what? 3.57. So A becomes 1.6 over 3. This is 0.05. 4 times 0.05 plus 2 times 0.06. So you have 4.49.
I think the previous one had 5.
So 4.49. So
This one the graph.
back to, so meaning that this rate, everything here is 4.49. So we say WCA naught over FA naught is equal to 4.49. So W becomes FA naught times 4.49 over C naught. FA naught is 12.1 times 4.49.
It's
That's 673.6. That's really amount of catalyst needed is 673.
Amount of okay, that's the amount of catalyst needed.
so we'll go from now.
You can say F A naught. What's F A naught? 120.
100.
Yeah, whatever
Yes,
is given.
FA not is not given.
It's given. 8. Okay.
There's some more business.
But this one don't need to label.
You can still put the
Okay, say okay.
The
Correct.
refresh, the refresh.
very easy, man.
The other